This is problem 11 on the Unit 1A review. State the transformations made to the parent function. Okay, what I notice here is that I have the absolute value function. So the absolute value parent function generally starts here at 0, 0, goes through 1, 1, goes through negative 1, 1. So this is where the parent function normally is. Okay, these are my normal points for the parent function. So I'm going to go ahead and write the table right here for this normal parent function. So this is xy, negative 1, 1, 0, 0, and 1, 1. This is the table for this parent function. Now, I'm going to look at this and say, where did this vertex move to get here? Well, I noticed that it moved 2 to the right. So the first transformation that I'm going to write down is a vertical, not vertical, that was horizontal, wasn't it? Horizontal shift right 2 units. Okay, so I went horizontally right 2, and then I went vertically up 1. So it's a vertical shift up 1 unit. Now the next thing I have to decide is, has this been stretched or compressed any at all? Well, I know these are my normal points, so I'm going to check these points first. I'm going to ask, is negative 1, 1 on my graph? I'm going to do that by pretending that this is the new origin. So here's my new pretend origin. I'm going to pretend like this point right here is 0, 0. If that point is 0, 0, go right 1, up 1. This is the point 1, 1. Go left 1, up 1. This is the point negative 1, 1. These are pretend points, pretending that I've moved the origin here. Now, these points are not on my graph. So what I'm going to do is find points that are on my graph, okay? And I can go, if I go over 1, I ask myself, how many do I have to go up to get to the graph? So over 1, okay, over 1, up 1, 2, 3. Over 1, up 3. Well, 0, 0 is still on my graph. Over to the negative 1, up 1, 2, 3. So negative 1, 3 is on my graph. So now I'm going to compare these and say, oh, look, the x's have stayed the same. These are the same. The y's have been multiplied by 3. I multiplied my y's by 3. If I'm changing the y coordinate, I know it's a vertical transformation. If I'm multiplying, I know it's either a stretch or compression. Since it's vertical and this number is bigger than 1, I know this is going to be a stretch. And it's going to be a stretch by a factor of 3. So there are my transformations to this graph. Okay, we're going to go ahead now and move to number 12 and see if we can get that one done in this same video. This one I do the same exact way. I know this is the quadratic function, and the first thing I'm going to do is see if my quadratic function is here, 0, 0, and it's looks like this. Its normal points are negative 1, 1, 0, 0, and 1, 1. Okay? So now what I have to do is say, okay, here's my new vertex. What have I done to get here? 1, 2, 3, 4. So I'm going to write them right up here. This is a horizontal shift. And I forgot what I said. 1, 2, 3, 4. 4 units left, or left 4 units. I don't care which way you say that. And then from there, I went down 1, 2, 3. So a vertical shift 3 units down. Okay? Now, I'm going to put my pretend origin here. So now I'm going to pretend that this is 0, 0. And I'm looking to see if these points are on the graph. So left 1, up 1. That's not on the graph. Right 1, up 1. That is not on the graph. If I go left 1, I'm going up just a little bit. I can't really tell what that fraction is. So instead of going left 1 and up and figuring out what that is, what I'm going to do is instead I'm going to move over here to this point and ask myself, if this is the origin, what is this point? Well, that is left 2 and up 1. So that's the point -2, +1. This point is 0, 0. And then I'm going to do the same thing here. I'm going to ask myself, what is this point? The reason I'm doing this point is because I can't really tell what this one is. So this point is over to the right 2 and up 1. That's the point that's on the graph. So now I'm going to compare these two graphs. This is the parent function, this is my new function. And I'm going to say, look, the y values are the same. The x values have been changed. They've been multiplied by 2. And since I'm multiplying the x's, I know that's a horizontal change. Since I'm multiplying, I know it's a stretch or a compression, and I can look at this graph and tell that what I've done is I've stretched it out. If this graph was here, it would look like this. Sorry, that's not a beautiful picture. But you can tell that I've grabbed it right here and stretched it out. So that's a horizontal stretch by a factor of 2. Okay, so all I'm doing here is stating the transformation.